We have another passionate speaker coming now who's going to talk about system earthing and equipment earthing. He is Dr. Rajesh Kumar Aurora, the most passionate is seen in YouTube quite often. And he's a senior manager, technical design and engineering, Department of Delhi Transco Limited. He has presented his papers in national and international seminars and written many articles on leading magazine. So I have a request to the speakers who's going to come keep 15 minutes buffer because there are too many questions coming in, so we can take a question answer also and a more interactive session. Over to Dr. Rajesh Kumar Aurora, sir. Welcome, sir.
Thank you. Good afternoon and namaste to everyone. Dr. Rajesh, a learner, a passionate person who always talk about safety and earthing, who talk about prevention of accident, always talk about safety measures, is with you one-to-one right now. And I have given a very relevant and important topic, earthing and grounding for protections of equipment, assets, human being and livestock. This topic itself is a very relevant topic because whenever we come across any accident, we have only two culprits we find in every studies, in every inquiry: short circuit and earthing. We don't have any other option but to blame these two things. And I am here to talk about that culprit with you, and I'm going to share my experiences. Next question, very relevant question, is why this topic of earthing and grounding and why Rajesh Aurora? The answers are very simple. This is the most neglected subject so far electrical engineering is concerned. We are ready to spend crores of rupees for any buildings or any projects, but we are not ready to allocate any funds for the safety. I am a researcher and it becomes my duty to do something for the nation I am living in. I have to get a bit from my side as a contribution to make my nation free of accident. This is our news. We talk about big diseases, we talk about big things, but this is a fact: electrocution kills nearly 30 Indians a day. And every fire in the hospitals, in the commercial buildings, finally blames go to the short circuit. And short circuit has direct link with your proper, adequate earthing system. Every day you just see on your social media some news of electrocutions of persons during rainy seasons. It gives pain. Apav sir, Gopa Kumar sir, working day in, day out to educate people. BIS and CA is working hard to make regulations, but still on the social media, all these things are very common. It gives pain. We have to start thinking, who is responsible? Are you responsible? I am responsible. System is responsible. It's not matter of human being. Even animals are not spared. They also get effects of that electrocutions, negligence, non-tripping of systems, inadequate earthing system, grounding systems. Why these electrocutions and deaths? And there was one question: what magnitude of current can kill a person? This is the effect of current, and you want to read more, you can see IC 60479, part 2, part 2, part 1, part 2, part 3, part 4. This summary I have taken. And that depends whether your body is wet, it is dry, it is 60 hertz, 50 hertz, or high frequency. Also depends on duration. Definition of ground or earth. A conducting connection, whether intentional or accidental, by which electric circuits or equipment is connected to Mother Earth or some conducting body that may serve as earth or ground. It provides a path for the flow of electrical current back to the source to earth, if it is providing a dedicated path for that short circuit current to go back to the source. Now, time to talk about system earthing. We have these 5 common types of system earthing in our systems. Solid grounded system, that is called effective grounded systems. Resistance grounded, reactance grounded, reactance and variable, reactance grounded only. When I say affected grounded or earth systems, that is basically denoted by a factor that is called coefficient of grounding and earth fault factor. Coefficient of grounding and earth fault factors tell you the characteristics of grounding systems you are using. That tells you at the time of single phase to ground fault what is going to happen as a TOV for the healthy phases in the system. Now, for the distribution systems, we have these 5 types of earthing systems available. One is your TNS system, then TNCS, TNC, TT, and IT. T means terra, that means earth, and for neutral, S for separate, C for common. I for isolated. And every systems have their own significance. And for every systems, tripping or isolation, automatic disconnections is very important. For your very first systems, you have only choice to make it automatic disconnected is RCD. For your TN system, it is by overcurrent protection. And for your IT systems, you need insulation monitoring systems, IMD devices, to take care of the insulations of your system. When I say earthing or grounding, these are the frequently asked questions. The very first question, what is the fault current? And why to do that grounding? And how to do and how to design it? When I say designing, that means you have to choose the grounding conductor type, area of cross-section of that grounding earthing conductor, total length of earthing strips and earth pit, toe level step and touch potential, attainable touch and step potential. Finally, you have to check your design after commissioning of your system. There are lots of confusion when I say earth. Some people give different definitions of earth and ground. And this should be the very first takeaway of my session. There is no difference between the earth and the ground. Both must be used synonymously without any further differentiation. And that has only been explained at IS 3043, page 3. You can also see the same thing in IEEE 80. I have talked much about, I have used that word earth and ground, but there are only 8 different purposes, and I tried my level best to make it simple. There are only these 8 purposes I have written here for any earthing and the grounding systems. Because at the time of fault, you need a dedicated path up to the source to go back. You have to talk about safety of living beings around the vicinity of your system. You have to ensure proper functioning of your protection systems under fault condition. You have to limit touch and step potential within tolerable limits. You have to limit the earth to face voltage, and you have to avoid the arcing ground. You have to avoid thermal stress on your equipment. You have to provide a path of discharge for external unwanted energy. Last but not the least, you have to provide shield against external unwanted charges, EMC. All these functions, whatever I have stated here, will be explained through picture to make you understand in a simple way. Flow of fault current to the source. Mind it, for every fault happens in your systems has to go back to the source. And how fast you can make that fault current back to the source is decided by the earthing systems you are using. You always look across, you always find, you come across ambulance on the road. What happens? Whenever you come across ambulance on your road, you always try your best to give part to that ambulance to reach to the hospital so that the patient in that ambulance can be saved. In the similar fashion, when the fault happens, to protect your equipments, costly equipments, you need some dedicated path. That dedicated path itself is an ambulance, and the patient inside ambulance is that faulty equipments. Think about it. When your patient can reach home, reach hospital, the person at home, your family, feels happy. Similarly, you have to make that fault current back to the source so that the electrical power system should feel the same happy moment. Otherwise, there will be hazard. If your patient are not reaching to hospital within time, similarly your equipment may fail. This is the role of a good, adequate, well-designed earthing system. This is a one way to provide that dedicated path. If you look it here, I have given that dedicated earth to take care of the fault current. This is a one way. This is a second method to provide that dedicated path to that fault current to reach to the source through earth mesh or equipotential system. This is the third way to make that fault current to back to the source with bonding, earth mat, and dedicated earth. But these three cases are not applicable when you go outside for your transmission system. Then the role of shield wire or OPGW wires comes that helps you to provide a dedicated path for that fault current to back to the source. Arcing ground is a phenomena when the voltage of your healthy phases becomes high or more than system voltage, equal to the system voltage for a fault in one phase with respect to earth, SLG, single line to ground fault. And that makes your gadgets in the houses to fail. In short, opening of your earth connection at distribution transformer causes this kind of incident. When I say thermal stress, when the current starts flowing, there is heating effect of that current, and heat comes in the contact with oxygens, and when some combustible materials are there, one thing is bound to happen, that is the fire. You can't stop it. Then electric shock. If you can provide dedicated earth path for that fault current to back to the source, that electric shock also can be avoided. What happens when there is a fault and the fault starts flowing through your electrode? around that electrode there will be one thing that is called the earth surface potential, and because of that ESP there is another term, touch potential and the step potential. This earth surface potential is responsible for most popular word, touch potential and step potential. These are basic interpretation, pictorial interpretation to understand that concept. This also brings some other dangerous voltage apart from your touch potential and step potential. It also brings GPR, TGPR, ground potential rise, transient ground potential rise, mesh to mesh voltage, metal to metal touch voltage. All these terms are associated with earth surface potential, and earth surface potential is associated with flow of current in the earth, mother earth. Picture to make you understand what that earth, step and touch potential is. Sometime within your systems, when you start touching two metallic objects in the same premises, be careful about metal to metal touch voltage, and that can be avoided with proper bonding and equipotential systems. Otherwise there will be potential difference between the two hands touching that metallic part, and you will get a shock for sure. At point number 7, I have talked about external unwanted energy. It is depicted by that picture. When lightning strikes on your equipments, you need some systems to protect it, and that can be protected by proper and adequate earthing. Then comes your building. Lightning protection need proper down conductor, and down conductor must be connected to your earthing system. Last but not the least, shielding, functional earthing is governed by that fundamental rules of Faraday's law. When you shield something and allow that external discharge to go to the earth with proper connection, nothing is going to harm. This is depicted by that picture. And when I say designing of earthing system, it starts with a measurement of resistivity, knowledge of short circuit calculation, calculation of the area of conductor required, density of current, resistance of earthing systems, human safety that includes your tolerable touch and step potential and GPR. These are basically flowchart to understand how that initial designs are made and it is checked, and finally you have to ensure the safety. When you talk about some medium voltage or high voltage substation, that earth mat, risers and equipment earthing to risers becomes important, and it needs proper calculation as per IEEE 80. Every design of earthing system starts with very first step of measurement of resistivity, and that itself becomes important, and that depends on the presence of conducting salt, moisture content, temperature and level of compaction. Proper, accurate method to be adopted for measurement of resistivity, because that is the backbone of your design. Garbage in, garbage out. If your measurement of resistivity is not accurate, no software can help, no method can help. be careful. And the most common method for that measurement is your Venner method, 4 pin. This is how this is measured. Sometimes we also use this Lumberjay method. The only difference is that here all electrodes are placed equally distant. Here these are not placed at equidistance. That can be varied. Traverse for testings. If you have that commercial building of big size, these are the actual recommended method for measurement of resistivity. Either you can do that one, or you can start from the center and you can go to the all 8 directions. You can use polar method, you can take average, you can take two or multi-layer soil model. That depends on the strata of that soil in that vicinity. It may have 2 layers, it may have 5 layers. Sometimes the first layer have more resistivity than the second layer, and sometimes the first layer have low resistivity than second layer. You have to design accordingly. It's not fixed, it is to be designed. And safety margin, that depends on the resistivity you measure and you just calculate. Up to 25, that means it is high corrosive, you have to take 30% safety margin. Up 400, 50%, and more than 100, no need to take any safety margin. This picture gives the impacts of salt, moisture, and temperature. Soil resistivity also weather dependent and depends on one particular day of particular month you are measuring that resistivity. That will definitely vary, and you have to use that measurement value wisely for designing of your system. Otherwise, you will end up with over design or sometimes under design. Be careful. At the end of your commissioning, you have to actually measure that thing, whatever you have designed, whatever you have implemented, it up to mark or not. When I say resistance of electrode or earthing system, it comprises of metallic part, resistance of point of contact between that electrode and ground, and resistance offered by that earth. And out of 3, the important part is that resistivity is converted into earth. Resistance of earth offered to that electrode to flow, to make that current to flow in that Mother Earth plays vital role. If your resistivity is already 100 ohm meter and you want to make it 1 ohm by inserting some magic electrode, that is not possible at all. Because the main contribution is of that Mother Earth in the vicinity of your earthing system. With some methods you can improve, but you can't do magic. For all these things, the important part is the short circuit understanding of the systems you are working in. And these are the normal transformer ratings we usually come across: 25 kVA, 63, 100, 160, 250, 400, 630, and corresponding to that DT you are using in your system, I have given some short circuit level. And based on that short circuit level, you have to design, you have to select your earthing conductor, your electrode. This is the one side of story. Here comes the second side. That is called split factor. Whenever the fault happens in the systems, all that fault currents never uses your Mother Earth to go back to the source. It takes help of your overhead wires, it takes help of armor, it takes help of screen of that cable to go back to the source. But every time we design based on 40 kiloampere, 63 kiloampere, 50 kiloampere, 31.5 kiloampere, without considering the impact of this split factor in the system. The second good aspect to be considered by all the electrical engineering while doing the design of earthing system. And this pictures depicts and tells you one thing, that merely connecting your system to earth is not going to protect you. If you haven't provided dedicated path for that fault current to back to the source, your earthing won't give you, that won't ensure that you are not going to get a shock. Because to get a shock, 30 milliamperes is sufficient. And that depends on your position of, that depends on values offered by your earthing system. Talking about 1 ohm, 2 ohm is irrelevant things. You have to provide particular earthing systems so that your fault current can reach to your source in a minimum possible time. That ensures the safety. When the system is not earth, it becomes unearth, and unearth itself is a disaster. In the absence of earth, the system becomes unearth, and unearth itself is a disaster. We have to avoid it. Now, time to talk about the takeaway of this session. Earthing and grounding are same. Earthing system to be designed based on the site requirement and applications. Fault current needs dedicated path to source. Last but not the least, very important point, OLOE should be the mantra. One location, one earthing. One earthing system, for one location is a takeaway. Electrical accidents give pain. Do you feel that pain? Do you feel pain when accident happens? Tell me. Yes. Don't you think we must contribute to eliminate the electrical accident? We must do it, and that is possible with a pledge. I request everyone sitting here to stand up for a minute and take a pledge to make my India free of accident this time. Everyone, please stand up for a less than a minute. I take a pledge. I will follow all safety rules and regulations. And also I will make people aware, whosoever comes in my contact, about the importance of safety rules and regulation. And I will try my level best to make my society, my city, my country, my nation, my India, free of electrical accidents, fire accidents, especially because of poor earthing, poor designing, or negligence of safety rules. Thank you, everyone. And this is not the end, it is a new beginning. Thank you, everyone. Thanks a lot.
Nice, nice. I know people got some exercise getting up and woken up. Okay, ladies and gentlemen, just another 5-6 minutes more. Thank you, sir. Wonderful. You kept us very enlightened and energetic throughout your presentations. Wonderful. I think my photographers have taken up your video, and I'm sure that you will be posting in your YouTube channel. Okay, we have this whole conference is successful in a way because of certain sponsors. So we have a platinum sponsor today called Sonal. Oh, sorry, I forgot. Oh, yeah, yeah.
I am
Sorry.
here to answer whatever question comes in your mind.
Okay. Yeah. One question, please. Please pass on the mic here. Sonali, we have sponsors here. Ask them to come forward. Yeah, this side. Question to Dr. Rajesh Kumar Aurora. Yes, sir.
Dr. Aurora,
Yes, sir.
there is a eternal confusion regarding this OLOE because when we are doing earthing for the specialized system UPS and X-ray machines and MRI centers and all that, you are talking of one earth, one location. And when we are trying to explain one earth, one location to the manufacturers, the manufacturer blatantly refuses it. And if we insist, he says the whole warranty issue will be on you. What is your take on this?
Okay. Very well question, and I would like to answer in a very simple way. This is the very first step of a journey of 1,000 miles. And I have taken that step, and you have to become the part of that journey, and you have to start educating, you have to give references of the course, and Gopakumar has been working on that particular OLOE for many years, and Apau sir is there, he can share his view also. And if you start working on that OLOE, definitely one day the people will start accepting it. I am quite sure about it.
One question then, subsidiary. If we are able to understand this from you, why can't you arrange a seminar with these manufacturers and explain the thing to them? Because it will be very simple for us to follow the things then.
Okay, and basically I am not working for a private company, I am a government employee. I don't have that kind of potential to arrange one webinars and collect people. If somebody arranging that webinar and inviting me to be there, I will definitely be part of that one.
Yeah, good questions, and I think NFE can
Sir.
take up that. Yeah.
Oh, one second. Sorry, because of throat, I couldn't make your answer. It's a very valid question. There are confusions among the installers, even including the manufacturers, as to where they have to connect the neutral with the body, especially in UPS and sensitive electronic equipments. Because of noise earthing, I have a separate presentation for that. I will send it, you will understand. Based on IEEE 11,646 and IS 732 and one more IEC 61936 part 1 we have forgotten. That they have amended. They have amended in 2021. Our IS 732 has come into effect in 19 itself. So whenever the field people are going to install the equipment, they have to refurbish themselves. They can't be totally, when a sensitive or a typical intervention comes into picture, you have to understand the latest provision of that particular aspect. I would like to send, I have sent it to Mr. Kirish, I will send it to you also. Unfortunately, I couldn't. In Chennai, I will have a 2-hour presentation on sensitive equipments, EMC and EMI, as well as overall. Sorry, I couldn't.
Before I say thank you to everyone, I would like to say one thing. In the absence of earth, there will be an earth, and be down to earth and be grounded and stay connected with people. Thank you, everyone.
Thank you, Dr. Rajesh Arora.